Hi guys, and welcome to HSC Chemistry, the industrial chemistry option, and this particular one looks at the implications of the Frasch process. In the last video we had a bit of a look at how we extract the sulfur from sulfur deposits under the ground. We know that there's a couple of different places from which we can source our sulfur, but ultimately one of the things that we need to focus on is this Frasch process. And the Frasch process occurs when we have a sulfur deposit which is under the ground and we want to bring that sulfur to the surface. The short way of just to recap that is that we have three tubes basically. One of the tubes is going to involve water at very high temperature and pressure, well, relatively high temperature and high pressure, in order to melt the sulfur that's in the deposit and to create an emulsion. Air being blown down a second tube is going to force that emulsion up through a third tube. So we have a sulfur-water mixture which is actually returning to the surface. When it does so, it cools, and as a consequence of that, we have solid sulfur and liquid water as our products. Once that sulfur mixture cools, we can then easily separate the sulfur out. But this process has a couple of important implications that we need to just consider, and they are the subject of this video. The first thing we need to do is to look at the properties of sulfur that actually help facilitate the Frasch process. The first is the fact that sulfur has a low melting point around about 113 degrees Celsius. And this is less than the superheated pressurized steam, which is at around about 160 degrees C. So when we heat the water up, it becomes steam, but keeping it under pressure makes sure that it will behave in a way that enables the creation of an emulsion once that steam is pumped down into the sulfur deposit. And this way we get a nice frothy emulsion, and this helps us to effectively blow the mixture back up through the third tube in the same way that when you blow into a drink through a straw, you get those frothy bubbles, and if you blow hard enough, you can actually force that liquid up and out of the glass. We also need to make sure that when we start pumping pressurized air into our deposit, that we're going to have that emulsion, that mixture, coming back up through the third tube. We don't want to leave some of it down there. We don't want to leave the water down there, preferably as well, but we want to make sure that we don't leave any of the sulfur deposit behind. For this to be an industrial process, we need to think economic benefit, and so therefore we want to minimize our costs, maximize our yields, and in order to do that we need to make sure that we have recovered all of the sulfur, or at least the absolute maximum amount of sulfur that we can from a particular deposit. The fact that the sulfur is insoluble in water is another important property, because this enables it to form a precipitate. It means it won't dissolve in the water. We won't have to go to the trouble of actually evaporating all of the water. We can simply use a technique like filtration, which is what we've done in the past when we want to remove a precipitate from water, a substance which does not dissolve or is insoluble in water. We can remove that through the process of filtration. Of course, the important thing with filtration is it's lower energy. It's a much lower energy process than something like evaporation, and so therefore it's that usually industrially lowers costs. The other important thing about sulfur is that it has a lower density than water, and therefore it's going to be floating on top of the water. This the frothy emulsion means that you're going to end up with a sulfur forming on the surface of the water, and that just makes it easier for us to get it out of the underground deposit and bring it to the surface. This is such a good method that you get about 99.5% purity. So whatever sulfur is in the underground deposit, we can get a very, very high portion of it out using the Frasch process. Unfortunately, there are some environmental implications with the Frasch process, and we need to just briefly talk about those as well. The first and the most Concerning is the fact that sulfur readily oxidizes to one of these salts, and we know that this is a problem because it leads to formation of acid rain, and all of the arguments that applied when we were looking at sulfur oxides in the acidic environment topic still apply now. So if we're going to produce sulfur dioxide or sulfur trioxide, they're going to be atmospheric pollutants, potential initiators of acid rain, and also respiratory irritants. There is another product which we may get as a result, as a consequence of the bringing the sulfur to the surface. If it's not oxidized to form one of these, it may be reduced to form hydrogen sulfide. Hydrogen sulfide is often referred to as rotten egg gas because that is exactly what it smells like, and it's horrible. And it's an atmospheric pollutant and a respiratory irritant, just like the other two. So we don't really want a lot of that produced. The water that we use for the process may contain, or it may even dissolve, some impurities as a consequence of its use, and therefore if we just release it may cause pollution in the surrounding environment. So one of the ways of dealing with that is that we often recycle the water during the fresh process in order to minimize the amount of pollution that we're introducing into the environment. Finally, once you've taken all the sulfur out of this deposit, you've got a hole, basically, where that sulfur existed before. Backfilling can be a little bit of an issue in this case because there is a big chance of mine subsidence. We can't easily fill that space that we've just created by extracting all of the sulfur, and as a consequence you can have problems with mine subsidence, and that can lead to things like land slippage or sinkholes, those sorts of things. So this is another potential problem associated with the fresh process. The key in the fresh process is to understand how it works, what's going on in each of those three pipes, and to understand what properties of sulfur allow the process to occur and what potential implications there are on the environment. In the next video, we'll have a look at what happens to the sulfur now that we've extracted it. Thanks for watching.